Right, let's move on our topic to the instructions level. So after we talk about task, program, and routine, so now we reach to a new topic, new subject, add-on instruction. The short name is AOI. So below you can see there are two my personal comments on the AOI. So first one, this AOI is a very similar idea to the UDT, user defined data type, right? So that's what we talked about before. If you are not familiar with this, I will post the link so you can have a look. So basically, this UDT idea is that as a programmer, as a user, we can define our own data, right? So on top of Boolean, double integer, timer counters, we can create whatever is suitable for our purpose as a new data type. So we can also use this new data type, create tags and use in the logic, right? So similar to that is that we can create new instructions, right, to suit our logic, right? So that's the first one. And when we design this new instruction, we have to provide a interface. So the interface uh, is mainly on the parameter side, right? So you can see here, based on the concepts of program and JSR parameters, and that is from the previous video, right? So you use the interface. I will talk about more. I would like to see what do I mean by interface, right? So we already use the concept of interface, all right? So I'll just use a demo process to create a new instruction of addition of 3 numbers. So we know with the PLC, we have a built-in system provided instruction as addition of 2 numbers. As a practice, right? So we just I just want to add one more, so I can add 3 more numbers together, right? So you will see the process. Also, there's a menu regarding of the add-on instruction from Rockwell, all right? So I will also post the link so you can have a look by yourself. If you want to go into more details, I only introduce some of the basic features, all right? So as you can see here, right? So with add-on instruction, you can create new instructions of a set of commonly used logic, right? So we talk about that, but provide a common interface, right? So you will see that to the logics, right? And intend to be used to encapsulate. Encapsulate, so that means you pack everything together as a package, right? So similar to the UDT, right? So with UDT, you can have different numbers, right? You can have a Boolean, double integer, timer, array, all kinds of tags into one package. So that's the idea of UDT, right? So same thing. We move on actually, it's related. We move on with the packing of the data into one. We carry on, then we also include logic into it, right? And the logic is very similar to, as you can see, I demonstrate on the JSR. It's almost like a subroutine, but you pack the logic and the data into one unit. So this is what we call the add-on instruction, right? So it's better to do a demo first, so you will know what it's like. All right. Let me see on here. Yeah, I need to resume the window so you can see better on the file. Okay, so all right. Right now, you can see on this program, I don't have any logic in it, right? So like I said, if you just type in ADD, though you will see that's a built-in instruction, right? So you have the source A, source B, add the two numbers together into the destination, right? So for example, we can just quickly see how it works. Tag 1. So you can create a new tag right on the instruction. Source B, you can also create a tag, but this time I can just use what we call the immediate number as number 5, right? You could have a tag, but you can also use numbers. But with destination, you have to create a tag to hold the result, right? So I can call that tag 2 here. So with this, you can see you have this is what I call interface, right? So we already use them in the regular instruction because it has a what I call the format interface. You have 3 parts exposed to you, right? You can set up those 2 numbers and then you get the result on here, right? So that's what I mean by interface. And with this program running, you can see in the real time, right? 0 plus 5 equals 5. If you change the tag value to 2, and then you will see the result as 7, right? So that's how the instruction running, right? So I can also create a similar instruction like this. So if you already create on that, all right, so you can see on top, follow my cursor, underneath the language elements, that's what they call, right? So there's a group called Add On. So when you click on this, you can see I already create at least 4 more add-on instructions, right? So if you click Add 3, right? That means you choose 3 on this, right? You can do anything any way you want. You can maybe put on the back on there. So you can see it looks like a regular instruction, right? With the ADD, right? And also you can see the interface. The interface is that you have I use the number, I use P1, P2, P3, represent the 3 numbers you can add together, and the result is in total. So of course, those names you can make a change as you want when you design it, right? And they work in a similar way, right? So for example, we can we can just use the tag 1 into P1, and P2, we can also use other numbers, or P3, you can use tag 2 on there, and we don't need this instruction now. All right, so now you can see with total, you need to create there's a question mark, right? So you need to create a new tag, right? So I can create tag 3, right? So doesn't matter the name, right? So then, it's good on here, but still, this is something different. You can see there's another question mark, right? So that means you have to set up this, right? And with the old one, you can see on the ADD, that's the difference, right? With the built-in instruction, it doesn't have the actual tag, but with the add-on instruction, you have to create a new tag, right? So when I create new, you can see here. So because I create the new tag right on the instruction, so that's why you can see here with the data type, the software automatically set up as the data type as ADD3. So this is similar to UDT, right? This is a new data type. There's no such data type before. Because I create a ADD3 instruction, then the system also create a new data type as ADD3 uh, to uh, to associate with this logic, this new instruction, right? So as I go through later on, as I go through the defining process, you will see why is that, all right? So for now, we can just give a name, right? So what we have on here is that for this add-on instruction, we won't use that in this location, right? So that's why it's better to gain a meaningful name. So for now, I can only see that I use _1. So that means this is a tag associated with addition of 3. This is on a one _1 location, right? Of course, if you want to create, if you want to use ADD3 again in a different location, you have to create another tag. You cannot share. So that's why I use _1 for this particular one. Then you can carry on with the _2, the 3, something like that, right? So it looks like the interface is all set up. It's all good. So we can finalize it. Once we finalize it, you can see it's on here. So now you can see tag 1 is value of 2, 2 plus 3 equals 5, and plus the 7 equals 12, right? So if we want to make it simple with 1, you can see here, right? If we can also change 1. So 1 plus 3 plus 1 equals 5. So it works fine, works perfectly, all right? So then if you want to know what exactly happened with this new ADD3 instruction, right? So you can right click and then you can see there are two options: open instruction logic, open instruction definition. So definition, I will do that later. So let's basically define the original design of this instruction. But if you want to look at in the real time, you better choose this open instruction logic on here. So if you open it, then you will see behind this ADD3, right? It looks like one instruction actually is just like a subroutine. Now I just use two ADD, the built-in instruction to add them. I first add P1 plus P2, then send the result to a tag called sum. Then use the sum to add on top of the P3, get to the total, right? You understand the process, right? So interesting that on here, you can see, you understand the process, the mathematical process, the operation. But over here, this is like internal, inside the black box, right? I do use a tag called sum, but you can see here on the outside, when this instruction exposed to the outside user, it doesn't say anything. You don't even know from here it has a tag sum inside this logic, right? So that's part of the meaning encapsulate, right? So you package everything inside a instruction. So you don't want outside to know a lot of detail. You don't have to know, right? You only need to expose P1, P2, P3, and total, so that as input and output. So again, it's like a concept of black box. So you are outside, you're a user. As a user, you only see outside of the black box, right? You have 3 number pass in, then you get a total come out, right? So that's basically the encapsulate meaning on there, right? So this is how do we use the add-on instruction, right? When we finish, right? Of course, I will demonstrate how do we create this from the beginning, right? So let me switch to a different file. Okay, so on here, all right, so this is another file. I don't have the ADD defined yet, so I'll go through this process. If you remember, the UDT is underneath the folder of assets, right? So underneath the controller organizer, you have assets, right? Similar to that. So that's why I mentioned UDT, right? If you open this folder, you have one subfolder called add-on instruction. That's how you start, right? And then when you open the data type, you see here, there's a user defined, right? So that's the UDT. So now we need to start with this folder, right? Similar to UDT, right click, and then you will have option add new add-on instruction, right? So of course you can export and import. That's a different features once you have that defined. So we'll create a new instruction, right? So like I said, we want to call this time I'll use capital, right? I can even add a _3, something like that, right? So again, as long as legal name, you can do anything you want. And also you can see here it has some major minor revisions. You can keep tracking on that, right? So that's again also other features, right? On the description, you can talk about what it does. With this one, it's very obvious, right? So we don't have to do anything. So we just need to give a name, right? So once we click OK, because we check this box, open definition, right? So you will see a definition window pop up, right? So this is the window on here. So if you don't see this window pop up, you can even add on later. So for example, if I close this window, right, but still you underneath the add-on instruction, you already see the name on there, right? Because we created the click OK. And also I want you to see on here underneath the data type, right? Remember, that's the UDT, user defined, right? So now there's another folder called add-on defined. You can see open here, it has a ADD3, right? So that means when we create an add-on instruction, the software will automatically create a data type to associate with this instruction, because within this, you will have to define the interface, the parameters, right? So let's go back to there. So it looks like a program, right? So like a routine on here, logic was there, right? So if you right click, you don't see that on the window on here. If you right click, you will see here, there's a property, right? When you choose the property window, you go back to the window I just closed on here, right? So it has different tabs, right? Underneath the general that's basically the first one. Then the second tab is called parameters, right? So it has two system defined parameter. So it's called enable in, enable out. So notice here on the usage, it has input and output, right? So I did a video before to talk about the input and output parameters. So this is similar to that. So these two are system created, right? So you didn't do this. You didn't do anything before that, but the system will create that for you. So what it does is that when you put your instruction in series or in parallel, doesn't matter, into the program, right? So for example, this is your new instruction. We just call ADD3. So that's also will appear on the future program on there, right? So you have logic go into there, right? So this is what they call the enable in, right? And the output is from here to carry on the continuity, right? Remember on the logic, you need to have logic continuity to go through, right? So for example, if you have exam on there, and then you have the output, something on here in your logic, you need to pass it's just like the current, right? Think about electrical current flow through the contact, then go through different device to move on to the next one, to the coil, right? Just like that. So that's why those two parameters is created by the system. You don't need to do it, but the software will automatically do it for you, right? So on top of that, you can start create your own, right? If you remember